Imagine sitting beside a crackling fire on a cold night nearly 100,000 years ago. Your stomach is empty. The darkness beyond the flames feels alive. Somewhere just outside the circle of light, a huge predator is moving through the shadows. You spot it before anyone else. You want to warn the person across from you, so you open your mouth, and nothing meaningful comes out. No words, no sentences, not even a sound carrying a shared meaning. Because there was a point in human history when language simply didn't exist. It's one of the strangest facts about our species. Every conversation you've ever had, every joke, argument, song, speech, text message, and whispered secret traces back to a time when humans had none of it. The journey from silence to speech may be one of the most important transformations that ever happened on Earth. And the fascinating part is that we still don't know exactly how it happened. The mystery begins with a major problem. Unlike bones, tools, or ancient artwork, language leaves almost no physical evidence behind. Archaeologists can uncover a spear made 50,000 years ago. They can discover fossilized footprints or ancient campsites. But they can't dig up a conversation. Words disappear the moment they're spoken. Speech is made of vibrations in the air, and air doesn't survive for thousands of years. That means scientists investigating the origins of language are forced to become detectives. They must reconstruct an ancient story using tiny clues scattered across many fields of research. They examine fossil skulls. They analyze throat anatomy. They study genetics. They investigate brain evolution. They look at cave paintings and ancient artifacts. Then they combine all those pieces into theories about how language emerged. And those theories are extraordinary. Before we can understand how language appeared, we need to answer a basic question. What exactly counts as language? Because communication and language are not the same thing. Animals communicate constantly. Honeybees perform elaborate dances to direct others toward food sources. Dolphins use unique whistles that function almost like personal names. Chimpanzees employ calls, facial expressions, and gestures to share information with one another. Communication is everywhere in nature. Language is something much rarer. The difference comes down to symbols. A signal is direct. When a dog growls, the sound itself communicates a threat. The growl and the message are essentially the same thing. Language works differently. Take the word fire. There's nothing inherently fiery about that collection of sounds. The word doesn't crackle. It doesn't glow. It doesn't produce heat. It's simply a symbol that people collectively agreed would represent a particular idea. That's a remarkable concept when you stop to think about it. Every language on Earth is built from sounds that only carry meaning because millions of people agree that they do. In a sense, words are shared inventions. They're imaginary symbols that entire societies accept as real. And the moment humans learned to use symbols rather than simple signals, everything changed. That shift transformed the human mind. It allowed people to discuss things that weren't immediately present. It allowed them to talk about yesterday. It allowed them to plan for tomorrow. It allowed them to imagine things that had never existed before. In many ways, civilization begins with that leap. The challenge is figuring out exactly when it occurred. Scientists have debated that question for decades. One group argues that language evolved slowly. According to this view, our ancestors gradually expanded their communication systems over hundreds of thousands of years. Simple calls became more flexible. Gestures became more sophisticated. Meanings became more complex. Over vast stretches of time, those improvements eventually developed into full language. This idea is often called the continuity hypothesis. Supporters point out that our closest relatives already display primitive forms of symbolic thinking. Chimpanzees can learn signs. Bonobos can use symbol boards. Some apes appear capable of understanding the objects of names. If that's true, perhaps language wasn't a sudden invention at all. Perhaps it was simply the final stage of a very long evolutionary process. But not everyone agrees. Another camp proposes something far more dramatic. They suggest that language emerged through a sudden breakthrough. At some point between roughly 100,000 and 50,000 years ago, something changed inside the human brain. Maybe it was a crucial genetic mutation. Maybe it was a new level of cognitive complexity. Whatever the cause, they argue that it unlocked a completely new ability, the ability to build complex thoughts inside other thoughts. Consider a sentence like, "The hunter who saw the animal that crossed the river returned to camp." That sentence contains ideas nested inside ideas. It's a level of mental organization unlike anything seen elsewhere in nature. According to this theory, humans suddenly gained access to that powerful cognitive tool. Language didn't slowly grow. It exploded into existence. This idea is known as the discontinuity hypothesis. And while researchers continue to debate the details, many believe reality probably lies somewhere between the two extremes. Language may have emerged through a combination of gradual changes and critical breakthroughs. To understand how, we first need to examine the human body itself. Because speech isn't just a mental achievement, it's also a physical one. Creating human speech requires a highly specialized vocal system. And for much of evolutionary history, our ancestors likely lacked it. One of the most important structures involved is the larynx, commonly called the voice box. In most mammals, including chimpanzees, the larynx sits relatively high in the throat. This arrangement offers a major advantage. Animals can breathe and swallow at the same time, reducing the risk of choking. It's efficient, it's practical, but it also limits the range of sounds they can produce. Humans are different. Our larynx sits much lower. That lower position creates a larger vocal chamber, allowing us to generate the incredible variety of vowels and consonants needed for speech. The trade-off is obvious. We're much more likely to choke. The discovery of the Neanderthal hyoid bone was already exciting, but then genetics entered the picture and made the mystery even more fascinating. In 2002, researchers identified a gene known as FOXP2. Almost immediately, headlines began calling it the language gene. That nickname spread quickly, although most geneticists weren't thrilled about it. The truth is far more complicated. No single gene creates language. Human speech involves countless biological systems working together. Still, FOXP2 earned its reputation for a reason. People born with damaged versions of this gene often experience serious difficulties with speech and language. They struggle to control the precise movements required for speaking. They can have trouble forming words, constructing sentences, and understanding grammatical patterns. Clearly, FOXP2 plays an important role in communication. What made the discovery so significant was how unusual the human version appeared. The gene exists throughout the animal kingdom. Mice have it, birds have it, even reptiles possess versions of it. But humans carry a unique variant containing two specific mutations not found in our closest living relatives. Those mutations appear to have been strongly favored by natural selection. In other words, evolution invested heavily in them. Then scientists managed to extract DNA from Neanderthal fossils. When researchers examined Neanderthal FOXP2 genes, they found something astonishing. Neanderthals carried the same key mutations as modern humans, the exact same ones. That discovery changed the conversation overnight. If both species possess those mutations, then the adaptation must have existed before humans, and Neanderthals split from their common ancestor hundreds of thousands of years ago. Suddenly, the roots of speech appeared much deeper in time than previously believed. By at least 400,000 years ago, our ancestors likely possessed much of the biological machinery necessary for spoken communication. By 60,000 years ago, Neanderthals appear to have had vocal anatomy capable of producing complex sounds. And somewhere along that timeline, human brains became capable of symbolic thought. But that raises an even stranger question. What were the first words? Unfortunately, nobody knows. And that uncertainty has produced some wonderfully creative theories. One of the earliest explanations is known as the Bow Wow theory. The name sounds like a joke, but it was a serious proposal. The basic idea is simple. Early humans created words by imitating sounds around them. A barking animal inspired one word. Thunder inspired another. Running water inspired another. Modern languages still contain examples of this process. Words like buzz, hiss, crash, and bang clearly resemble the sounds they describe. The problem is that such words make up only a tiny portion of language. You might imitate a bee. You might imitate thunder. But you can't easily imitate concepts like freedom, justice, memory, or mathematics. At some point, language requires entirely abstract symbols. Then comes the equally memorable poo-poo theory. Yes, that is genuinely its name. This theory suggests that language began with emotional vocalizations. The cry of pain after an injury, the laugh of amusement, the gasp of surprise, the sigh of relief. These sounds are deeply rooted in human biology and likely existed long before language. However, they're mostly instinctive. People don't consciously invent them. That makes it difficult to explain how they transformed into structured communication systems with grammar and syntax. Another proposal is the yo-he-ho theory. According to this idea, language emerged from rhythmic sounds made during cooperative work. Imagine groups of people pulling ropes, dragging logs, or rowing together. Their synchronized grunts and chants could have gradually evolved into more organized vocal patterns. As strange as it sounds, many scientists think this possibility deserves serious consideration. Music and language activate overlapping regions of the brain. Some researchers even suggest that singing may have appeared before spoken language. If that's true, our ancestors might have been making music long before they were making conversation. Then there is perhaps the most charming theory of all, the ta-ta theory. This idea proposed that speech originated from gestures. Early humans communicated primarily through hand movements. Over time, vocal sound began imitating those gestures. Eventually, spoken signals replaced physical ones. Today, few linguists accept the original version of this theory, but the broader concept behind it remains influential. Many researchers believe language may indeed have begun with gestures, and there are compelling reasons to think so. Consider the human brain. One of the major language centers, known as Broca's area, sits close to regions responsible for controlling hand movements. In non-human primates, similar brain regions are heavily involved in processing gestures and facial expressions. The overlap appears too significant to be coincidence. Then there's pointing. Pointing may be one of the most important communicative acts humans perform. A simple finger can direct another person's attention toward a specific object or event. Interestingly, human infants learn to point before they learn to speak. Chimpanzees in the wild almost never point in the same way humans do. That pattern has led some scientists to suspect that language may have begun with the hands, while the voice arrived later. If so, our ancestors may have been conducting silent conversations long before they ever spoke a word. But anatomy and gestures alone cannot explain language, because language depends on something even more important, the human mind. Specifically, a remarkable cognitive ability called theory of mind. Theory of mind is the ability to understand that other people possess thoughts, beliefs, desires, and intentions separate from your own. It sounds simple, but it represents one of the most profound abilities humans possess. When you speak to someone, you're doing something extraordinary. You're not simply making sounds. You're assuming another mind exists. You're assuming that mind can interpret your intentions. And you're trusting that both of you share enough understanding to connect meaning with words. Language is essentially a bridge between two separate consciousnesses, a kind of controlled mind reading. So far, we've looked at the physical side of language. We've explored the throat, the vocal tract, the hyoid bone, and surprising evidence suggesting that even Neanderthals may have been capable of producing complex speech. But anatomy alone doesn't create language. A parrot can mimic human words. A computer can generate sounds. Neither truly understands what those sounds mean. Language requires something deeper. It requires a mind capable of turning noises into ideas. And this is where the story becomes even more fascinating. Because one scientist began looking beyond bones and vocal cords, they discovered that the biggest breakthrough may not have happened in the throat at all. It may have happened inside the brain. One of the most important clues came from genetics. In the early 2000s, researchers identified a gene called FOXP2. Almost overnight, newspapers began calling it the language gene. That label spread quickly, although many scientists disliked it because it oversimplified a much more complex reality. There is no single gene responsible for language. Human speech depends on countless biological systems working together. Still, FOXP2 attracted enormous attention for a good reason. People with damaged versions of this gene often experience severe difficulties with speech and language. They struggle with the precise motor control needed to form words. They can have trouble understanding grammar. They often find it difficult to coordinate the complex movements required for fluent speech. Clearly, FOXP2 plays a significant role in communication. What made the discovery even more intriguing was the fact that humans possess a slightly different version of the gene than other animals. The gene itself isn't unique. Mice have it, birds have it, even crocodiles have it. But the human version contains two specific mutations that are absent in our closest living relatives. And those mutations appear to have been strongly favored by evolution. Natural selection seemed to preserve them for a reason. Then scientists made an even more remarkable discovery. They extracted DNA from Neanderthal remains. When researchers examined the Neanderthal version of FOXB2, they found something unexpected. Neanderthals carried the same critical mutations as modern humans, the exact same ones. That finding had enormous implications. It suggested that the genetic foundations of speech appeared long before modern humans emerged. Since humans and Neanderthals shared a common ancestor more than 400,000 years ago, those adaptations must have existed at least that far back. Suddenly, the timeline for language became much older. By hundreds of thousands of years ago, our ancestors may already have possessed much of the biological machinery required for speech. The vocal system was developing. The genetics were falling into place. The brain was becoming increasingly sophisticated. Yet one giant mystery remained. What were the first words? Unfortunately, nobody knows. And because we have no recordings from prehistoric humans, scientists have been forced to rely on theories. Some of those theories are surprisingly entertaining. One of the oldest explanations is known as the Bow Wow theory. Its basic premise is simple. The first words were imitations of sounds found in nature. People heard animals, thunder, wind, or running water, and created words that mimicked those sounds. Modern languages still contain examples of this process. Words such as buzz, hiss, click, and bang clearly resemble the noises they describe. The problem is that imitation can only take language so far. You can create a word for thunder. You can create a word for a barking dog. But how do you create words for concepts like friendship, justice, memory, or imagination? At some point, language requires abstract symbols. And that's where the Bow Wow theory begins to struggle.